So, good morning, everyone, and this is lecture number 4. And in this lecture, we intend to finish the string and the pulley problems because we'll have to pace up a bit. Okay, in the last class, we had done some problems. I hope you understand them, and the problems were pretty damn simple. What we had done was we had some pulleys, some masses pulleys. There was no problem, so pulleys problem will come today. We had just seen that if all the blocks are moving one acceleration, you can take them as one system and solve the question correctly and quickly. Do we remember this question that we did in the last class? We took different blocks as one system and then we found out the effective force. Yes or no?
Yes, sir.
Well, we will begin today's class with questions that are going to come in your examination hall, and the quicker you solve them, the better you will become. And the first question is the most common of them all. You would have seen this question. This gentleman is known as an Atwood's machine. Do you know an Atwood's machine?
Sir, come again.
It is known as an Atwood's machine. So this is an Atwood's machine. So this is question number 1. This is an Atwood's machine, and we have to find out the acceleration of the block in this Atwood's machine. So known as the Atwood's machine. It basically has one pulley and two blocks, M1 and M2. You can assume that that M2 is greater than M1. If M2 is greater than M1, then how will the system move? M2 is greater than M1. How will the system move? Huh? How will the system move?
M2 moves downwards, M1 moves upwards.
M2 moves downwards, M1 move upwards. You have to find the acceleration of the two blocks and the tension in the string. You have 2 minutes to do this. Yes, do we get the answer, anyone?
Sir, T1 equals to M1 into G minus A.
What are the known things in this question?
Sir, acceleration is m1 plus m2 by m1 minus m2 into g.
Okay, what about T? M1 plus M2, okay, upon M1 minus M2. See, the known things are M1 and M2, and the acceleration is downwards acceleration due to gravity. These are the only things that are known to you. So your answer should come in terms of these things. I'll give you 1 more minute because I want you to do it on your own. Try it again. 1 minute. Okay, let me do it for you. We'll draw the free body diagrams. M2G, tension T, tension T, tension T, tension T, M1G. This block is going to move down with an acceleration A. This block is going to move up with the same acceleration A. Do we understand this?
Yes, sir.
Let's make the equation, sir. This is M2G, this is T, and this is A downward. So what is the equation of this block? Tell me.
T minus m2g equals to ma.
Where it is going? Do you see the direction where it is going? Again, make the equation. Try again. You will only learn by your mistakes. You never learn from reading from the board. You never learn that way. Learn from your own mistakes. Look at the direction. Try again. Try. Clock is moving downwards. Try. Try again. Try. I'm not going to do it for you. Trust me. You'll have to do it on your own. Try. Tell me the answer again. How did you make equation? The previous cases where it is moving, you make equation in that direction or you make equation in your opposite direction? Where it is going? Do you see that? Where is the block moving, bacha? Do we see it? Where is the block moving? Second block, where is it moving?
Downwards.
Now make the equation. It is moving downwards. Now tell me the equation.
Minus t minus 2mg.
Try again. Try again. Net force is equal to ma. Try. If you try on your own and you get it, you will never forget it.
Sir, m2g minus t equals to ma.
Ma.
Sorry, m2a.
See, if you try, you succeed. M2G minus T is equal to M2A. That is correct. Now you understand the difference between the equation that you were telling me and the equation that is correct? And do you understand why it is correct and why the other one was wrong? Do we understand this, everyone? Yes or no?
Yes, sir.
Raise your hands, everyone. Everyone has not raised their hands. Do we understand what was wrong in the first equation and what is right here? The block is moving down. You have to take downward minus upward, not upward minus downward. We understand this? Now, be patient. Look at the free body diagram and tell me the equation for this block. Once you understand the basic concept, you understand the question and no one will be able to deceive you with any variation of the question. Tell me what would be the pink equation?
T minus M1G is equals to M1A.
See, once you understand the concept, and once you understand the concept with your own hard work, you are never going to forget it. Do we understand this?
Yes,
Now
sir.
you can simply add the two equations. If you add the two equations, t will get cancelled and straight away you will get the value of a. I will just write the value of a. The rest I will leave to you. Find it out, write it. It will come as m2 minus m1 into g. It is exactly opposite to what you were telling me, upon m1 plus m2. Do we understand this? Do we understand how these equations are made, my dear friends?
Yes, sir.
Pakka?
Yes, sir.
If you want to remember the value of tension, it is 2 times m1 m2 upon m1 plus m2 times g. That is your tension of this Atwood's machine. Will you remember it? Yes or no? No or yes?
Yes, sir.
Pakka, sir? कच्चा वाला पक्का और पक्का वाला पक्का सर? नो पक्का सर? पक्का no sir?
Yes, sir.
Okay, let us come. I'll give you 1 minute if you want. Have you noted down this question? If you noted down this question, I will move quickly on the next one. Shall I?
Yes, sir.
Yes, sir. What about the others, sir? Okay, now the next question looks like this, and I hope you don't get confused. A block is hanging like this, and one block is kept like this. Let us say that this block has a mass m1. Let us say this block has a mass m2. There is no friction anywhere. First of all, tell me what is going to happen.
Sir, which mass is greater, sir?
m2 is greater than m1. Yes, tell me what will happen now.
So the system will be in equilibrium.
No, that is not the case. Why do you think system will be in equilibrium? m2 is greater than m1. Any reason for that?
M1 will not drag.
Remember, there is no friction here. What will happen? Anyone with a different idea? Like to share it with me? What is going to happen in this case, my dear friends? There's only one thing that can happen, that will happen. And that thing is, this block will go down with an acceleration a. This block will come here with an acceleration a. Do we understand this?
Yes, sir.
There's only one thing that is possible. No other thing is possible. It has to move down. There is no friction. There is nothing to stop it from going down. So now I ask you, what is the tension in the string? And I ask you, what is the acceleration of the two blocks? And that is the answer you are going to give me.
Sir, one doubt, sir.
Yes.
Sir, will tension in the string will be always equal, sir? In every place of the string.
Yes. Do you remember what we had written? Had you written those notes on tension and string? Can you just go back? Go back and read notes on tension and string. Read. Something was mentioned about the tension in the string. Can you read it out for me loud? So that I also know that I had given something, or probably I had forgotten to give.
All strings are massless.
Yes.
Strings are inextensible.
Right.
Strings are ideal.
Right.
Tension remains same.
So I said something, right?
Yes, sir.
Now ask the question again. Is there any doubt left?
Sir, my doubt is that, sir, here M1 is in acceleration due to gravity.
Okay.
And M2 has no acceleration because there is rigid surface.
No, it has acceleration in the forward direction.
In forward direction, sir. But here acceleration due to gravity is acting more, no, sir.
No.
One
Acceleration
additional
due
force
to
is added.
acceleration due to gravity is always G. Does not change.
I mean that acceleration due to gravity is one extra force, no, sir, here on M1.
No, it is also on M2. In fact, M1, M2 has extra force, normal reaction from ground. What has that got to do with anything else? What has that got to do with the two blocks attached to a string? Imagine two blocks attached to one string. Can this happen that one moves with a different acceleration and the other moves with a different acceleration? Is this possible? Yes or no? Okay. Is there any other doubt?
No, sir. Thank you.
Then please solve the question with whatever we know, and that should be good enough for you to solve the question. I see a new girl. Do we have a new girl in the class? New student in the class? Yes or no?
Yes, sir.
What's her name? I mean, give her the mic so that she can tell me her name at least.
Good morning, sir.
Good morning, beta. How are you?
I am fine, sir. What about you, sir?
I am doing great. Do you understand anything that is happening in the class?
Sir,
Do you understand anything that is happening in the class?
I am understanding, sir.
Oh wow, that's great. I did not expect it. So you are
Sir,
able to understand how we are making the equations. Do we understand it?
I am unable to hear you, sir, clearly.
Do you understand how we are making the equations?
I am new to the class, sir.
Do you understand what is happening in the class?
No, sir.
Okay. Sit. We'll cover this topic and then we'll move on to the next one. Then probably you'll be able to understand. You'll have the recording of the lectures. You can see that. 1 or 2 lectures. You can take the notes of your friends, and that
Okay,
will
sir.
help you. Okay.
Okay,
Chalo.
sir.
The
Thank you.
only thing that we are doing right now is F is equal to MA. We find the net force and equate it to MA. That's it. Find the net force, equate it to MA. Net force equal to MA. Net force equal to MA. That's all. Okay. Your 2 minutes is running out, my dear friends. Yes, my dear friends, do we have anything that looks like an answer? How did you try it? Did you try it? Everyone tried it. Shall I do it for you?
Yes, sir.
Not able to do it?
No, sir.
Okay, may I know what's the reason? You don't understand how to do it? Okay. Let me
Sir,
yes,
for
beta.
M2 we cannot getting equation for M2. M1 we got equation, but M2 we are struggling to get equation.
Struggling to get equation. Okay, let me see if I struggle also. We draw the free body diagram. So this one is M1G, this is T, this is T, this is T, this is T, this is M2G, and this is N2. You got this free body diagram, yes or no?
Yes, sir.
Now you look at this N2 and you look at this M2G. It cannot move like this. So what is the value of N2?
M2G.
So you told me that you did not get the equation for M2. You got equation for M2. Now look at this. Look at these two things and tell me what is the equation for M2 in the x direction.
T is equals to M2A, sir.
Is it so difficult that you could not get it on your own and that you had to need my help to get this equation? Was it such a difficult equation, bacha?
No, sir, but we are doubtful at that, sir. T equals to M2A.
No. Why are you doubtful? If this C is not equal to empty, then that means whatever we have learned goes down the drain and it gets flushed into a nala and it's going down.
We got that, but we are doubtful at that equation.
No, that is correct equation, beta. Don't doubt your thing. Now we have this. What is the equation for this?
M1G minus T equals to MA.
M1G minus T is equal to M1A. Now you can add these two equations, get your answer and stay happy. Do we understand this? Yes or no? No or yes?
Yes, sir. I got the same thing, but I am doubtful at that M2 equation.
No, that is correct. Anyone understand this?
Yes, sir.
Clear? Okay. Everyone has noted this down? I'll give you 1 minute. Note it down. And then we can move on to the next one in the line. Don't worry, beta. I have told you the basic method of solving. Don't mistrust what you know. I know that you know, and I want you to get that confidence that that is correct. That is the reason I give you time to solve. There's no other reason of wasting so much time. I could have done 10 problems here on the board, but it's not the number of problems that I do on the board, it's the number of problems that you do by your own hands that is going to matter. Do we understand this? I may have done 25 problems, but even out of 25, you will not even understand one. But if I may only do 6 problems, I may only show you 6 problems and you are able to do those 6 problems, then my task is done. That is how I look at it. Do we understand this? Yes or no?
Yes, sir.
Have you noted it down?
Yes, sir.
Now let us move on to a similar problem and let us see what difference does it make. And try to understand it. And if you understand it, you will be able to deal with problem. Oops, that is going to come. Let me put it like this. Okay. Now I have a pulley. I have a block like before. This block, let us say, is 10 kgs. I have the same string. Remember, it's the same string. I have one block. Let us say this is 5 kgs. And I also have one force. which acts like this. And this force is 120 newtons. Then I ask you the same question. What is the acceleration of the blocks? And what is the tension in the string? I'll give you 2 minutes, think about it. Just bacha, you now got to tell me where is this system going to move? Yes,
In the direction of force.
in the direction of force. Why? Because there is a force, that's why.
No, sir. Here acceleration due to gravity is 100 Newton.
No, that is not correct. Again, rephrase. You have said the right thing, but use the wrong words. You have said the right things, but you have used the wrong words.
Okay. The force due to acceleration due to gravity is 100 Newton.
Say that again. See,
And
the force which is trying to pull it down is 100 newtons, but the force which is trying to pull it up is
120 Newtons.
therefore it cannot go down, it has to go up. Do we
Up.
understand this?
Yes, sir.
If, please check, please see, if I make this force as 100 newtons, if I make this upar wala force as 100 newton, then what happens?
Equilibrium.
That is the case, bacha. Remember you said in the first case that it is in equilibrium. When both forces are equal, beta, then it will be in equilibrium. Do we understand this?
Yes, sir.
Now, if I make this as 100 newton, then the system will not move. If I make it more than 100 newtons, the system will move upwards. Do we understand this? If I make it less than 100 newtons, the system will go downwards. Do we understand it now? See, there is no physics involved. This is pure observation. Yes or no? There is no physics involved.
Yes,
A small
sir.
kid can tell me this 100 is more or 90 is more. So if 100 is there, this body will go down. Yes or no? Okay. Now you know the concept. I'll give you 2 minutes. Do it as soon as possible.
Sir, it's done.
Okay, then tell me what is the answer that you are getting, my dear friends.
Acceleration is equals to 1.33 meter per second square.
Okay, well done. Everyone got the same answer. So how are we supposed to do this? Let me draw the free body diagram. Oops, wrong. This is T, this is T, this is T, this is T. Yes or no? This is 50 and this is normal reaction N. You can straight away tell me the value of N. N is equal to 50. We don't need it now, but we'll be needing it afterwards. Now let us make the equation for this block. CT C100, and we have to also understand it is going to move like this with an acceleration A. This is going to ulta. It is going to move up with an acceleration A. It is going to move up with an acceleration A. What is the equation for this block? Let me write the equation. I think the mic is not working. The equation for this block is 120 minus T is equal to 5A. Yes or no? 120 in this direction, T in this direction, acceleration is in this direction. What about the equation for this block? Look at this, and look at this. What is the equation for this block? T minus 100 is equal to MA 10A. Yes or no? As soon as you add this, you will get 20 is equal to 15A. You can write A as 4/3 meter per second square. That is the answer that I was looking for. Do we understand how it is done, my dear friends? Anyone got it? You got the concept, more importantly. Everyone got the concept correctly? Yes or no? No, yes. Okay, let me present this case now. And let us see how you do this one. Remember, all the questions are simple. If you feel that every question is difficult, you will not be able to solve it ever. So the first thought that should come to your mind is that the question is simple, and I have forgotten which number it is. So I'll just call it question number 5. I think it is question number 5. And this is the question. Block A of mass small m is placed on a smooth slope, is connected by a string with another block capital B of mass capital M. This mass capital M is greater than m sine theta. I don't know what it means. As shown in the figure, initially the block A is held at rest and then set free. Find the acceleration of the block and the tension in the string. Your time of 2 minutes starts now. Do you understand? What is the question? First of all, the first thing you have to tell me is, how does the system move? So you can understand it, whether block B moves downwards or whether block B moves upwards.
Sir, block B moves downwards.
Why block B moves downwards?
Sir, their mass is greater than m sin theta, no, sir.
Okay, so if I draw the free body diagram, capital MG is here, T is here. If I draw the free body diagram of this, small m, G is here, N is here. Yes or no?
Yes, sir.
But you will have to break this m into two components. So this component will become small mg sine theta, and this component will become small mg cos theta. You remember this, my dear friends?
Yes, sir.
This is T and this is T. Now you can see that the force which is trying to pull it down is this one, and the force which is trying to pull it on this side is this one. Who is going to win?
Mg.
Capital MG will win. So
Capital M.
the block will move downwards. This is the hint. 2 minutes now to solve the question. Give me the answer and stay happy. Yes, my dear friends. I'm waiting patiently for the answer. My patience is running out. Yes. 1 more minute.
Yes, sir. Sir, acceleration. Sir, hello.
Yes, beta.
Sir, acceleration is equals to capital M minus small m sin theta into g by capital M plus small m.
Well done. That is correct. I think it is correct. Good, good. And then once you get the acceleration, you should be able to find out the tension in the string. Yes or no? No or yes?
Yes, sir.
Everyone got the same answer? Everyone got the same answer? Yes or no? No or yes? No one got it. Girls, no one? Okay, so you make the equation. This is going to go down with an acceleration a. This is going to come up with an acceleration a. We understand this. This block is not going to move like this. Dhar, 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 dhar. So n will be equal to mg cos theta. Do we understand this?
Yes, sir.
Now just make the equation for the block in the y direction. You look at this t, you look at mg sin theta, and you look at acceleration upward. What is the yellow, what is the pink equation looking like? Look at the pink things. Tell me what is the pink equation?
T minus mg sin theta equals to small m into a.
T minus mg sin theta will be equal to small m into a. How many of you were able to make this equation? Please raise your hands. All of you. And it's all half of the question. What is remaining? Now look at this, whatever color is this. Look at this and tell me the equation for this one.
Capital Mg minus T is equals to capital M into A.
That's it. These are the two equations. As soon as you add up the two equations, you will get the value of A, and the value of A that you will get will be capital M minus small mg, capital M minus M sin theta. G will be common for both, divided by, my dear friends, M plus small m. Do we understand this? Yes or no? This is gone about. Say bye bye, bye bye. I'm going. Please don't stop me. I'm going. I've had enough of you. I'm going. Got this?
Yes, sir.
Yes, sir. No, sir. I have sent you the sheet. I'm now going to give you two quick problems from the sheet, and you will have to do it as quickly as possible. These are the types of problems that are in fashion these days, and everyone loves fashion. Girls love fashion, boys also are still doing fashion. So these are the problems which are in fashion these days, and let us see if you are in tune with the fashion of today. The first one comes on your screen. This is problem number 20 from the sheet that I have sent you. I hope you get the sheet. Please confirm it with the office people. The sheet is there from Astik sir. NLM, Newton laws of motion. This is the sheet. I mean, this is the question from the sheet. Two blocks, 4 kg and 5 kg and 4 kg. It has a lot of questions on this. This is for your practice, and these are the questions that are going to come, my dear friends. Trust me. Two questions. Two bodies of block of mass 5 kg and 4 kg are tied to a string as shown in the figure. The table and the pulley are smooth. Acceleration of the 5 kg body will be equal to fast. The answer is given in terms of G. Get me the answer, D. Fatafat G. Do it fast. And ask for sir to give you the sheet that I have already sent it to you. G. What is the answer? G. Fast, G. Answer G. Fast G. We have no time, G. Answer G. Fast G. And the answer is
4, sir. Fourth option.
no, that is not correct. Try again. Try. And you shall not lose. This is question number 20, my dear friends. And the answer is 4. Yes, that is correct. Answer is 4. You said 4 or 2?
4, sir. 5G by 9.
5G by, as you said, 5G by 9. I thought 4G by 9, so I was like, no. 5G by 9, that is correct. Everyone got this? Yes or no? How are you supposed to do this? Tension T, they have drawn it. 5 kg is 5 into G. Do we understand this?
Yes, sir.
This is T, already drawn here, D. This is M, 4G. This is normal reaction. No one is going to ask you the normal reaction, so forget about this. The only way this system is going to move is downwards. Yes or no? Say yes or no?
Yes, sir.
with an acceleration a. So we'll just write the equation of this block. It will be 5g minus t is equal to 5a, and we look at the equation of this block. It is going to move in this direction, so the equation of this block becomes t is equal to 4a. Yes or no? No or yes?
Yes, sir.
We put this in block, we put this in block, we add the two equations, t gets cancelled. 5g divided by 9 is A, and the correct option is option number 4. Well done. Can I give you one more?
Yes, sir.
This is from your sheet. More questions are there in the sheet. The more the number of questions that you try, my dear, the better you are going to fare in the examination hall. This is the next question that comes on your screen right away without any fuss. Oops. I perhaps exaggerated it. Let me try to bring it back to its normal size. This looks good. This looks better. So here is the question for you, my dear friends. Done. 3 blocks of equal masses, 2 kg each, are hanging. This is again an Atwood's machine, but the only thing that has changed in the Atwood's machine is on the right hand side, instead of 1 block, I have 2 blocks. Every block has got equal mass 2 kg. What is the tension in the string connecting the weights B and C? Remember, the string is massless, my dear friends. String is massless. This sheet has I think how many questions? Oh, it has got around 109 questions in category 1, then around 80 questions, or around 100 more questions from the previous years. So if you can do these 200 questions, I can assure you every question that comes in the examination hall, you will be able to solve them. And the time that you will have to do these 200 questions is till Sunday, because from Monday we might start the next topic. That is work, power, and energy. So till Sunday, you will have to complete this sheet. Come what may, you will have to complete this sheet by Monday. So what you do? As soon as this class is over and you get time for your lunch, you go back to the office, find out this sheet, get this sheet, and start working it away. Do we understand this? Yes or no? No, yes?
Yes, sir.
More the number of questions that you do. Remember, to clear JEE, I have a very simple formula. Do you know my formula of clearing JEE?
Sir?
Do you know my formula of clearing JEE?
No, don't know, sir.
It is very simple. Solve 40 problems in a day. 40 problems for physics, 40 for maths, 40 for chemistry. Remember, when I say 40, those 40 must be those 40s with correct answers. So you might have to solve 60. Out of 60, you get 40. You might have to solve 80. Out of 80, you get 40. You might have to solve 100. Out of 100, 40 correct. Now, the day you start getting 40 correct from 50 questions, that day you are ready to appear for your JEE, Joint Entrance Examination. So I have given you 200 questions, 3 days, 60 questions per day. You must get 40 out of those every day. Correct. Simple, na? Simple or difficult? Okay, so I'll give this question as a homework question, and we will discuss this question moving forward. And in the next class, which is tomorrow, we might start with friction, and by tomorrow and after tomorrow, we might be able to wind up friction. So far, so good. Do we understand this? Remember, practice these questions, because these are the questions that are going to come, my dear friends. Okay. So I'll see you in the next class. Note down this question. The question is simple. Draw a pulley, 3 blocks, mass 2 kg each. You have to find the tension between the two strings, connecting B and C. I'll see you on the next side, on the next class. Take care, and may God bless all of you and keep you happy and healthy and safe. Bye-bye.